Hello and welcome back. My name is Mark and we are solving some of the Advent of Code exercises, things which I obviously closed. And the next is the seventh. We are solving it in Rust for some reason because we love our life. Cool. The next thing is the seventh day, and we will go through of this description and we will see how it is different compared to the previous ones, and we will solve it hopefully pretty soon. So, day 7. This year Santa brought a little Bobby tables, okay, a set of wires and a bitwise logical gates, okay. Unfortunately, little Bobby is a little under the recommended age range, okay, and he needs a little help assembling the circuit. Okay, each wire has an identifier, some lowercase letters, and can carry a signal, so this is a hash map-ish thing. Each wire has an identifier, some lowercase letters, okay, it can be multiple, not just the English alphabet with one letter, it can be more as well. A signal is provided to each wire by a gate, another wire, or some specific value. Each wire can only get a signal from one source, but it can provide its signal to multiple destinations. So this is like a graph-ish thing. A gate provides no signal until all of its input have a signal. Okay. The included instruction booklet describes how to connect the parts together. X and Y, which will lead to letter Z, means that the connects AND gate and connects the output to wire Z. For example, this is an input and the output. The second one is an AND, which is a bitwise AND. That's the left shift, right? Left shifted by 2, and the output is the letter Q, or the wire, or the part Q. Not E is F, which is probably the complement. Other possible gates include OR, right shift, and that's it. So we have the input output, the AND, left shift, NOT, OR, and right shift. Ooh, so this is one example, and we will have, or we should have, an output as well. Ooh, so the interesting thing here is sometimes the order matters here. I mean, most of the times the order matters here because, as I mentioned before, some of the input of this thing might be the output of a previous another part or partial thing. We might not go through these things linearly, but somehow we have to create a pool and assemble the graph, etc., etc. But I do believe, since this is the 7th day, quote unquote only the 7th day, we can go through it line by line and assemble or create this device that they've been talking about. Cool. Yeah, these are the things, and it should be the output. And what is the question? Yeah, Little Bobby's Kit instructions booklet. Yeah, this is the puzzle. What signal is ultimately provided to wire A? Ooh. So we have to, Cool. Open this thing. Go to the text editor of your choice. Yes, we are not using a Vim. No worries. This should be the 7th things, so the test should be something like this. Looking good. So this should be the test, and this should be the quote-unquote prod version. As you can see, this is not just one character, but this can be multiple ones. Yeah, this is LX and not 1X. I was afraid that we have some other things as well. So let's create the 6 prod 2, and we will overwrite it based on the input. We should create a new file which will hold or create the solution. We'll call the 7th, and we will get rid of all of the not necessary parts here. Yeah, not that, not that, not that. No. Yeah, yeah, we will see. Try from, so we need this and that. It should be 7th. The 7th day, exercise. First should be 2, second should be 2. And yeah, we don't need this thing, it's not working anymore. It should be 7th day, and we should include this in our librs to read the thing. It doesn't have any errors yet. Obviously, if I would run the tests, those would be included and failing. Let's add the new files. Yeah, and we obviously included it in here as well. We will create a commit that chore add 2015 7th day. I don't know, let's call it scaffold. Yep, just like this. Cool. So looking at the provided test folder. Wait, what did I just do? This should be, did I mess up this thing? No, it's looking good. So this should be the 7th prod, but the 7th test should be this thing. Yeah, so based on the text, the good text, we should, it should look like, we can differentiate the different instructions. Obviously, it consists, and hopefully it should, it is consisting, a line which is separating the left and the right part. And what else? On the left hand, there might be one number or two things separated by and or left or right shift, or only one thing which starts with a not. Cool. So we should do something pretty similar we did before. So we should create something similar we just did for the 6th day. So it should look like something like, so we need an input and the output, and we can create an instruction, and yes, you're not correct, because it needs it should have a target. Let's call it a target, which is a string, which is on the right hand, and on the left hand we should have different things. So we should create an enum based on the operation. We can call it operation, and it might be based on different things. We learned from our previous mistakes. We should add partial, equals, clone, copy, and all of the interesting parts here. But this operation should be a simple assignment, which should be based on a number. I'm not sure if it should be only a positive number or not, but let's say that's a U32, because we will read one number and we will assign it to the right hand, and that will be an operation for the instruction. So this operation might be an and, but it should be based on two numbers. Or it might be, I don't know, a not. Oh, an or. Yeah, it's looking good. There might be a left shift, but it needs a U sides because we want to shift somewhat with left and right as well. And we should do the not thing. Yeah, the not and with this thing as well. So what do we need here? So we first of all should create this instruction somehow, but in order to do that, we should read the operation somehow from this thing. So we should, yet again, implement the try from stir, because we want to convert it from some part of the string, and the operation, the type of the arrow should be static. Ooh, what is going on here? Okay, so let's see what's going on. So it is collecting three things here, and based on if this thing exists or not, it is creating the operation. Let's revisit this thing. So we have a few things here, and it has an invalid operation. So whenever we have an assignment, let's start with the first one. So whenever we have an assignment, we are not even interested in this thing. And we should create one thing. Yep. Oh, yeah. So, yeah, the assignment can be the last. Give me a second. So what is the most interesting approach here? So whenever the length of this string is 3, maybe we should approach it that way. Split white space. Parts first, second, ok, or no second. No, it's not. I don't want it this way. So match parts. We should recollect. Yep, just like this. And we should say this is a vector of stir. If I will find the good buttons, maybe, looking good. So whenever the parts is 1, we should create an awk of operation assignment, and actually, yeah, I mean, we can or we should assume that we can just unwrap this thing. We should believe to the authors that the provided string is good. Cool. Whenever it is too long, and it starts, I mean, it consists two things. Oh boy. So the not is not. Yeah. So we have different options here, but maybe we should just keep the use sign, I mean the number everywhere, and we will switch the variables by their value. Yeah, maybe we can keep it that way. So whenever it's 2, I mean it has the length of 2, we should do this, and whenever the length is 3, let Copilot cook a little bit. It might be and or left shift and right shift. We will return with these things. Yeah, left shift, use size 2. Oh yeah, because we are ignoring these things. Yeah, and everything else. What? Underscore is not. Oh yeah, we should do it here. It should return with an invalid operation, which is a string. A string. Parts doesn't have to be mutable. Looking good. Let's give it a really quick test, and it should be function test parts. Looking good. The operation should look something like this. We should end it for now. We might add things later. We can how to skip it. I know we can skip it. Hello? Oh, ignore. Oh, yeah. Ignorance. Blessing. Cool. Cool. I mean, we can close this thing. So we should create most of the things. We should do it with one of the things, and we should create one if it would create this thing for us, maybe with all of the operations. Obviously I had a good typo. Yeah, and the interesting thing is that those will be letters. Yeah, we can't do this. I'm a stupido, moderately stupido. So the left shift and is let's give it a string. The right shift should be string as well. The not shift should be string as well. The or, because we are referencing, I should have add the I should use the stir with a lifetime, but I will not do this for now because I don't want to assign lifetimes and such. Tuple very undefined here. What? Okay, thank you. So we should not parse it, but just use this thing. Parts 1, and you might say 2 owned everywhere. We will see. 2 owned, 2 owned. The end, yeah, this is a star as well. No. Yeah, this is a string. The or is a string as well. Please, the shifts can hold these values. Cool, looking good. So these 2 owned, yeah, maybe not the best, but I will not worry about the lifetime annotations, although it should make sense. Assignment, yeah. Hopefully we won't have, I don't know, like X should be here and there, but we will come back if there are things that are not working. This stays just like that. Looking good. So we hopefully fix most of these things and we can read those. And coming back to this thing, the whole instruction should be read. Yeah, we can create one. We should implement the try from stir. For instruction, we should split by this thing. If it's not left and right, but it consists multiple arrows, that should be bad. We should create the operation from the left side, and the right side should be the target. Looking good. Cannot find. And not form, it's from. Cool. So yeah, that's one thing that we did. Actually, I will commit this. Why not? We added. Yeah, we fixed these. Added these. Yep. We ignored the test, but it's not bad. Chore. Add initial structs and traits. It's a bit vague, but it is what it is. So what should we do from now on? So we should read or we should collect the instructions based on these things. It's looking good. It's returning with the instruction vector. And we should calculate the values. And this should return based on a vector of instructions. It should be a vector of instructions. We should return with a hash map. I mean, we should overwrite the previous things, hopefully, probably. So the left side that we are interested in should be the name of the circuit board or the diode of the place. It should be a string. I'm yet again not worrying about lifetime annotation. I won't touch this thing here. And on the right hand there should be, I don't know, a U size, a U32. We will see. So we should create, and I will close this thing because we need a bit more real estate. Oh my god. Okay. So what's going on here? So we should create these values. We will return with the values at the end. And we want it to go through the operations. Why would hashmap new insert? Yeah. So we will read the instructions. So we should read the instructions, and we should read the already existing things, and based on the operation we should insert the new values if those are present. I am not sure if those will be here based on some initial ideas of mine. So I do have a fear, quote-unquote fear, that these things cannot be linearly assembled. So we should do some while, or we should do some exploration or building a graph, because you should, I don't know, like rotate these things or swap, etc. But let's see if we would put this thing here. So first of all, let's parse the instructions based on the content, calculate the values, and yeah, we should get the value A. Yeah, but we cannot really test it based on the test file, or can we? Is there any A here? No. So amazing. Yeah, it is what it is. So let's see if we would just run the tests for now. Let's comment out most of the things, and we should get something here. Hopefully not an error, but some okay, parsing this thing. Okay, so this should be an assignment, and okay, so we have an error here. Operation, try from this thing, but this looks like a valid thing, so this is actually this thing, and it should be pretty much valid. And the assignment, actually it should have I don't know, like a target or something. The nut, am I correct? Give me a second. So the test should have, no, it should have one value. And the operation will have one target, but this is this part, the instruction. So we should create one instruction in the test and not an operation. So this should be an assignment. Yeah. But no. Let instruction, and we should read those from here, and we should assert that it is 4, and the first one is yeah, we should so the first thing, why would it be 4? No, it should be 8. Let's run the test again, just with the numbers. We can ignore this thing for now. Yep, for some reason. Yes. Looking good. So the test parse failed. So the parse instructions thing failed. Okay, not bad. It should have 8 lines, and we should read all the instructions, and it should have eighth values in it from the example, which is which should be 7th. Oh my god! Oopsie daisy. And it's looking good. Cool, it's a little bit better. So come back to this, we should come back to this part. We should add this thing, run these tests. The first test failed because we cannot unwrap this thing. Yes. So we cannot read this thing based on the test, and this is what I've been afraid of probably, but let's debug this thing. Yes, so we have the current target is the D, and the operation is that we should what is it? Operation. Wait, what is this operation? Which is that operation? Oh, this is the end, probably. Because the left is, or should be, let's jump one. So the left is X, the right is Y, and we should do a left value and a right value. Let's jump 2 more, yeah. Okay, so let's rerun the debugging thing, and we should see if in the we should see that we already have some values here and there. Cool. So we have 8 instructions. Okay. Give me a second. So we should close this. Read the tests. So this is looking good. X, Y, we are assigning these things. The end, yeah. We should go line by line until this point. And I will debug this thing here again. Let's rerun this thing. So the instructions, let's look at them. There is none target, which is pretty much an interesting because we should have some target here. So based on the instructions, let's see what are no targets, empty target. What is going on? Yeah, it should fail. Yeah, looking good. So let's stop this thing, make it stop, and we should come back to the test. So we should not just read this thing, but we should check what is going on with the first test file, which should be something like the first thing should be, let's close this one, let's make this thing here. So the first element should be an assignment, and we want it to assign it to x. Yeah, and the instruction should be equatable. Looking good. So we can test it. So this thing should be, we want to assign x. No, this value to x. Let's add the second one as well. It should be pretty much the same, but it should be this, and we should assign it to y. Yep, let's rerun the tests. Looking better. So the first test is failing, but the parsing is okay. Not bad. And let's see another one, maybe with this left shift thing. This is the fourth by index. And it should be not an assignment, but a left shift. And it should be an x by 2, like this. And we should give me a second. We should have the target as the f, like here. We should shift the value of the x by 2. Operation left shift. We have too many commas. Yeah, looking good. Let's run the tests. As you can see, the parsing still looking good. So maybe we should come back to this thing and we should check things out. So the assignment is looking good. That's just an inserting. And let's look at the operations. Insert, left value. These are the bit and operations, so it's probably looking good. This is the bit, or it's relatively self-explanatory. Left shift, right shift, these are the bitwise operating stuff, and we are doing the negation here as well. So it should be good. My my guess here is that some of the things are bad because we do not provide the good values for the tests. I mean, whenever you open up this thing, we want to read the, what is it called? The A value, and we kind of cannot do this. We cannot say we can say not x because we know what's the x value. We can say not y because we know what's the y value. So this one should not be failing here. Not in the value. Let's put a debug point here and let's rerun the test because I want to see if that's x or y or something is acting up with this thing. Let's run it in debug mode. Let's stop it there. Yeah. We don't need you. No one needs you. No, not you. Let's go to the next point. Okay, here. And yes. Again. Let's close this one. Debug. Yep. Looking good. What? You should run in debug mode, sir. Thank you. So it did stop here or there, but it is not showing us any values. Prefix, expression, yada, coming back to this part. Yes, so we have a few, we have a panic here, the 100th line, which is this thing. It cannot read some values. Why? What is the value here? Why don't you stop? If I tell you so. Cool. So instructions. Let's see those. Yeah, have some targets. Looking good. F, G, H, Y, if I remember correctly. And the operation should be... What? What's the... Operation and target? What? So in the instructions... Oh yeah, they might don't... Yeah, we will see. So let's go through these things. Instructions, 8 of those. We should insert... Do we need to do this instruction operation? I'm not sure about this step, but... So the operations will be filled with this thing. And there will be 133, yes. And this is an addition, so it should be a passing one. And the other operations, for example, the D, should be something else because we will use the X and the Y. And hopefully those are executable operations. Cool, let's close this thing. Let's close this thing to have a clearer picture. And we are interested in the values because this is the thing that we want to return with. So after we went through all of the things here, we have the instructions, the operations, yeah, looking good. And if we start the operation, there will be a left shift. ¿Por qué? Interesting. Oh, I probably know the answer because the hash map is not really an ordered thing, especially not ordered by this thing. I'm not sure if we should start with the F. We should not start with the F. We cannot grab this thing, so we should not put these things into a hash map because it won't give us an ordered thing back to us. How could we do this? So we should rather get rid of this thing. Let's escape this thing. Yeah, we should do this rather, and it will keep the order. Let's run the test. Let's see what's going on. Yeah, so there is a none value here and there. Let's rerun it in debug mode, but not the parse, but this one. Let's see what's going on. So we do have these operations. The first one is assign this variable to x, so we should be safe to look at the values and such. So the operation should be an addition. This is the zero, I guess, and the target should be the x. The value should be 1, 2, 3 soon-ish. Am I correct? Yeah, so the values should be increased by this thing, and it is looking good. In the next iteration, we should have another assignment which will add y to the values, and after that there should be one new operation which is an AND. The left should be the x, yep, the right should be the y. So we will grab the left value and the right value. Let's look. This should be 1, 2, 3, and 4, 5, 6. And if you do the left and right, and if you want to reinsert it as a D, it should appear in the values. It is 72. Yeah, it's looking good. X and Y is looking good as well. Yes. Yes. And there will be one OR. The next one based on X and Y. Where are we? Or X and Y, which should be added as the E value. Should be the target. Yep. And the E is 507. Looking good. Yep. So let's go through the remaining things. So this is a left shift based on the value of 1, 2, 3, and we should add the F like that. Looking good. Yes. So the target should be G. Oh. Yeah. We will see the G should be 114. And the left, yeah. The G 114 looking good. What else? We need one more thing. I mean, two more things. We added age. Ooh. What is this? What is this? Oh, we have to use. Interesting. If you know how to read, you should recognize these two letters, the 1 and the 6. You probably would know that this is one number which represents 16. And if you don't use, values as 16 for the things that you want to, like store things here or there, those can be unsigned. Yeah, and the assignment should not even do that. Yeah, looking good. Yes, yes. Yeah, it might be better. We are inferring types here and there. Hash map should be this thing too. And we should not even do anything else otherwise. Let's do a debug once again, and let's do a really quick clicking around. Oh boy, and this is just the first thing here. Yeah, click, 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 click. We should have a few values already. They should be pretty much the same, but the age, when we get there, shouldn't be that big number. It should be a relatively moderate number. Almost there. Probably the next one. Yeah, this is the age, and we want to negate this thing, but it's still a big number. But it's looking good. 65412. Yeah, looking good. It's looking better. And the last one should be somewhat really close. Yeah, it's looking good. 65. Yeah. Maybe we have a solution. So let's see if we would run the tests. We should see some numbers here and there with the value, I mean the expected value. And obviously not an error. We don't have an A. Okay, that's interesting. None value. So it doesn't have any. Oh, corretto. So we should say unwrap or, I don't know, 0 as I32. What's okay, because in the test we don't even have, I mean, they give us test that does not include A, but they expect us to look up the A. Interesting, right? So the first test here should be 0, because there's no such thing as A here. And yeah, we will see. And hopefully in the next one there is something else. Cool, another issue. Invalid digit. Cool. So when we tried to parse the assignment, it was not a valid digit in the prod version. Okay, so 7 prod, when they have, ooh, yes. So this might be not just a number, because as you can see, we should be able, oh my god, yeah, and this is what I've been afraid of, that they do not start with, what is it called? Assignments, value assignment, but they rather start with references. Interesting. So we should look up eventually these things. I mean, we should order based on what operations they have, because we should probably start with these things, or we should do some while loops. So we should start with these things, and probably they would refer, let's see where the B is. So they will use the B to calculate the E, and my question is that, is it a valid assignment if you do not, I mean, if you are using the B as the value that you want to assign this thing? My question is that, can you use B arrow C or not? Because if not, then maybe we should do some ordering or some while loop and try to do a few things here and there. B, yeah, looking good. Huh. Yes, maybe we should order things based on alphabetic order. I mean, Oh, yes. Yes. They are doing such things. Bad. Bad things. Mm-hmm. Mm-hmm. We have a few options here. So, I've been talking about the grafting when, in order to resolve most of these things, you have to look up something which will just come maybe at the end. It is at the end, relatively at the end, when you specify what's the value of the b, but you're referencing it in many ways before that. So we should add a graph, and we should do that by creating a graph, and we should traverse that graph, and whenever you have this thing, you should assign the value to it. Looking good. I mean, this will be a route because you might have multiple ones, and you have to collect those things. So, yeah, I mean, I will take a break and continue from that point.